Hey guys! Thanks for coming back for another video tutorial of this account application. I want to thank all my new subscribers for some reason in Southeast Asia, especially in Thailand. I don't know what the deal is, but thanks for subscribing and watching the channel. That's awesome. Today, we'll create a middleware to extract a user from an ID token sent to our application on an authorization header. This ID token is the one we send to a user in JWT format when we have them sign up or sign in. This middleware will first validate the incoming request by verifying that we've received the appropriate authorization header. It will then verify that the token is valid and not expired. If these two steps succeed, the middleware will set the user on the GIN context so that route handlers can use the verified user data to make authorized updates for this user. And by authorized updates, I mean things like updating their profile or their profile image or some other details relating to that user. In some role or permissions-based authorization scenarios, the token might store a role, or the role might be fetched from a database based on either the user ID or some other ID, which is put inside of the token. In our application, each user will only be authorized to make changes to their own account info, so that'll keep things a little simpler. We're going to call this middleware authUser for authorized user, meaning to get the authorized user. I guess I could call it get authorized user. But in order for it to work, we're going to need to create a new method in the token service called validate ID token. As middleware here is a sub-package, which is why I put it inside a sub-package of handler, which is why I put it inside this little yellow or orangish box. The middleware will be able to receive access to the token service from its sort of parent package. I don't know how I like the middleware directly accessing the service layer. This may break some clean architecture principles, I'm not sure, but it is easy enough to just pass the token service from this orange or yellow handler layer down into the middleware sub-package of handler. As an example of how this auth user will be used, let's go back to the me handler which we created at the very beginning of the tutorial. We previously created this me handler, and in it we see that we extract the user using this GIN context.get, and this .get takes a key as a string, and then it doesn't know the type of the value you get, but there's a list of these keys, and I think it holds a map in GIN, and then we can then check if this exists, and if it doesn't exist, we can send an internal server error or some other error. It should exist because we're going to force this handler to have access to the user or to return an error as JSON before we even reach this handler. So if it doesn't exist, we'll log and then send an internal server error. But if the user does exist, then we cast it to a model.user. And all of this is to say that our middleware, instead of getting a user, it needs to first set a user with this string of user. And this user needs to be of type model.user, which we see here. And that's what this casting has to do. That's what we'll build today. If some of you were better than me and actually did more thorough testing, you might have seen some problems in the service layer's sign-in method. So if we go to user service here, and then scroll, we're already scrolled to sign in. I had a bit of a problem returning the user. If you notice here, we pass to the sign-in method a reference to a user, and then only return an error if there's a failure to sign up. Now, if I had to do this again, I would actually return a user, and instead of passing in a reference to a user, I would probably just pass in the email and password. And that way, we don't have to sort of mutate this user. But because of the way we're doing this now, if I set u equal to uFetched here, when this method gets called in the sign-in handler, if I open this here, when this gets called, this u actually won't be updated with the way we're doing things in the user service right now. So just as a temporary fix, and I would go and refactor this whole thing, but I don't want to update the unit test today. You may consider doing that. I'm just going to assign the values of uFetched to that of u. And then if we save this, this ends up fixing the problem. So what was happening is I was signing in a user, and then when you sign in a user, you might recall that the end value sent to user are the tokens. So we take the user and we create tokens from this user. So you see we create new pair from user and we passed in u. This is just a reminder of previous stuff. But then when I looked at the tokens did not actually have the user's ID. And if I went in the database and added more user details, those also wouldn't be stored in the token. So it wasn't actually updating u. Again, if I had to do this again, this method would actually return a user and an error. I now want to add the functionality for validating a ID token or an ID token. And we have a file already in the service layer, tokens.go. This is just utility functions used by the actual token service. Now that I think of it, I probably could have just put all the logic in this file, but it makes a little bit of separation and keeps our files from becoming terribly long. At the bottom, let's add this new method, or technically a function. I just say them interchangeably. You'll have to forgive me for lack of precision. All right, here's the validate ID token. It will take in the token string. This will end up being a stringified version of a JSON Web Token. It will also take the RSA public key. And this, if you remember, if we go to the token service here, there should be a struct. It receives a public key, and this is passed to the token service when we initialize the application in this injection.go file, and we call new token service and pass it an RSA key that we've previously created. It returns ID token custom claims. This is already in this file, and ID token custom claims just contains our model.user, which is in this models folder, and JWT standard claims, which will store things like the created time of the claim, the expiration time, who the claim's issued to or by, and things like that. So you can check this out and see what's in it if you'd like. Oh, here it is. Expires at, issuer, subject, and so forth. Let's scroll back down and see what's in this validate ID token. So we create an empty struct of those claims I just showed you, and then to parse claims with our JWT library, which if you recall is this DGRI Jalva. I don't know how you say the name, sorry. And it's the JWT-go package. So this tokens takes in the actual JWT token string, and then the claims, which is a reference. It's going to populate the claims of this ID token customs claims. Right now it's empty, but these will be populated if our JWT token key is valid. This library is a little odd. It will end up taking this sort of anonymous function or closure here that returns key, and this key is the RSA public key. And what this ends up creating is a token from the JWT library, and then on this token, we end up being able to check if the token is valid. So this library, when it parses the key, it will be able to, or when it parses the token with the key, it will be able to tell us if the JWT has been modified or tampered with, and if it's expired. It's not the clearest library to use, so I would recommend checking out the docs. If all goes well, we take the claims here and we make sure to cast them into our application type of ID token custom claims. I guess it's a service layer type to be more technical. And we just make sure that that casting works. It should, and we return these claims. So what we'll do with this is call this function inside of the token service.go. And if we go here at the bottom, we're going to add a new method called validate token. But of course, first, before we do this, we need to have that expectation. I probably should have defined all these interfaces a long time ago, but let's go to our interfaces.go file and let's add what our definition of the function should look like. So we'll have a validate ID token method. It will take a token string, meaning that JWT token string of type string, and it will either return a user, which is in this model layer, or an error. And that's good. And then, of course, we should have errors that these are not implemented. So let's first add an implementation in our mocks, which is in this model layer. And we're not going to do the testing here. There is some interesting testing code for this tutorial, so I recommend you check out the repository as we're going to add middleware tests. But let's go to token service. And I'm just going to copy and paste this code quickly. It's the same as all the other mocks. And make sure I add the comment correctly. So that will make the warning go away for the lack of implementation in the mocks. And if we go back to the interface, one more thing, do note that this method does not, the validate ID token does not receive a context. That's because our JWT functions don't require a context, and we're not going to be doing anything with a repository layer or database, which could end up canceling or modifying the context. So no need to pass it. Now, only now, let's close some of these. Let's implement this validate ID token in the actual token service. In fact, this is going to be a pretty simple method here. We call the validate ID token on the token service that we have here. It receives the string. This is just the signature we just defined in the interfaces. And we get the claims from validate ID token and make sure there's not an error. And in the case of any error here, as far as the user is concerned, let's just return an app error's new authorization error. So I think that's HTTP 401. Yes, it says right there. And say unable to verify user from ID token. Maybe you would even want a more opaque message. At the end of the day, the main goal is to return a user from off of the claims. If you remember at the very beginning, we looked at the me handler and we got a user here, and then it was expected to be of type model.user. We're now ready to create our middleware to extract the authorized user. So let's go here, middleware. We have one already. Let's add a new one, and let's call this auth_user.go. I really can't do a radio voice. Well, I have the scratchy, high-pitched voice. Why am I trying this? So here is the code for the middleware, and first of all, you can see my auto imports, and I want you to take care of this. Always, for some reason, I need to figure this out. They always import the validator version 9 package, even though Jin expects to use validator 10. Maybe someone who knows more about these tools can help me to figure out why that is. But here is the one you should actually use from Go Playground. I'll make sure to go mod tidy, run go mod tidy to make sure I don't have any packages stored I don't need. So let's save that, and it moved. Okay, so I said I had imports omitted. That's from my copied code, but they're actually here. And the first thing we do is create the type of the header from an HTTP request that we expect, and we expect to get one called authorization. So just as we can create these struct tags for a JSON body, we can create them to validate that we have proper headers when we're using Jin in tandem with Go Playground Validator. I also have this struct invalid argument. We used this earlier in bind data, which is a function here for binding our JSON data to struct types. And I just re-added it here, copied and pasted. Maybe you'll find a better way to do that. Here's the function auth user. Remember that it needs to access the token service, and it will be able to, from the handler layer, we'll pass it down to this function. And middleware, if you recall, need to return a handler func, and a handler func is just a function that receives the context. And that's what this is here, return a function with the context. We first create an auth header, which is this, it's empty, and then we use this should bind header method on the Jin context, which is very convenient. And if there's not an error, we first check if it's of type, our error is of type validation errors, and this is provided to us by the Go Playground validator. And if it is a validation error, we're just going to strip off the fields that matter to us, which are like field, value, tag, and param. Go ahead and look up what those contain in the docs. And then we're going to go over all of the errors, because this validation errors is actually a slice of field errors. Where does it say here? Let's maybe see what each individual error in errors is. You see it's a field error. So we just pull off these 4 fields from that. And then we're going to create a new bad request error, which is what you usually use for validation. And in that, we include this error message and the error type. And then the error type or HTTP status code will be retrieved from this. And then we also append the invalid args as a field and value onto this JSON. And of course, we don't continue down the gin pipeline of handlers. If there's any other type of error, we don't know what it is, so we'll just return status internal and then abort, of course. Otherwise, we take the ID token header. We're going to use strings.split to take this h.id token. Remember, h is the auth header, and it has the ID token field. We're going to split that with bearer space. Now, I don't know why the authorization header always has to have this bearer and space. I almost wanted to skip it, but, to keep with the tradition of having to split this string for no apparent reason, I'm sure there's some legacy reason, but I always see it with bearer space. And then after the space, we have the actual token. So here we're just splitting that. We're making sure that the split ID token header has 2 values. So if the length of this header is less than 2, we clearly don't have an authorization token of type bearer space token. So I send an error. Then we can finally reach out to this validate ID token method that we just created. And if there's an error, of course, we'll return a new authorization error. Now, I don't know if I needed to return an authorization error now that I look at it in the token service, but it didn't hurt, I guess. Because in any case, in this handler, we'll return the authorization error. And then we're going to set the user if this user is retrieved and cast to a user. We get the user off the claims, and we set it on the user key. And then we call the downstream handler. And today, that downstream handler that we'll set up is the me handler that we set up a long time ago. We configure all of our handlers and middleware in this handler.go file. And we do it here where we set on this group of routes. This is where we just set up our base URL. And then we set which HTTP handler routes with which verb, get, post, delete, and so forth. I guess and put, patch. I don't need to say and so forth. There are only a few of them. Then we set up which handlers correspond to them. So right now we want to handle this me case. But remember that almost at the very beginning, we set up the me handler to be tested in isolation of the middleware. So we're going to actually need to run this me handler without the middleware in test mode. So in this case, I earlier set up a timeout middleware that I only wanted to apply in like dev or production mode. And so we can do something similarly here where we only run the middleware auth user if we're not in test mode. Now, if someone has a better production way to handle this, I actually don't like putting this logic here. So in the comments, go ahead and let me know how you might handle it. As I said, I wouldn't call myself a beginner anymore. I'll give myself more credit than that. But I kind of work solo and I'm not on a big team and I don't see how they do these kind of problems. So any of your feedback would be great. But at the end of the day, again, I'll repeat, if we're not in test mode, yes, go ahead and apply the auth user middleware. And remember, we have to pass the token service to the me handler. Otherwise, if we are in test mode, just call h.me. And I can actually probably break up these tests to not call this new handler. I could probably instantiate the handler myself, and that might be a better way to go about it now that I think of it. But hopefully you're learning about some potential pitfalls. With all this set up, we should be able to run the application and make a request to the me handler with a token added as a header. So let's first cd up one directory as we are currently in our account folder, which is one of the sub-projects. Our Docker environment is in the parent folder, so let's run docker compose up here. All right, it looks like things are up and running. Let's use Postman. In the written tutorial, I just have some curl commands. So let's first maybe sign in our Guy1 user here. I think I might have even added some data to Guy1, like their web or image URL and their website. So we might get some more info here. Let's see. So let's first send this. Good. We get an ID token. Now, just for your information, in this test, I set up a little script, and there may be a better way to do this. I am clearly not a Postman expert, but I'm setting a variable called ID token with this data here, which comes in as a JSON data, tokens field and ID token. So basically, I'm creating two variables, ID token and also refresh token, that I can use in these other queries or HTTP requests. And let's see how that works now. If I go to my me handler here and go to authorization and then go to bearer auth, you can see that the token I'm using is ID token, and it's automatically populated with the value from when I sign in. So it's just a nice thing. If I want to use this quickly, I can, sign in, and then the me handler already has the ID token. So let's go ahead and send this and see what happens. All right, great. We get a user with an ID and an email. So it looks like I don't have these fields here, so I guess I lied. But we could actually go and update those in pgadmin and then redo this, and you would get the name and image URL. Now let's actually run this by getting rid of this header here. And you can see this header will be set here. It just does it automatically for us when we populate this authorization tab. But let's go and say turn this off. No, here. We don't need to go anywhere. No auth. And if we go back to headers, you see there's no auth header now. So hopefully we should get an authorization error of status 401. That's going to be it for today, everyone. Happy New Year. Thanks for joining me again. Remember that unit tests are available in the source code repository. Next time, we'll get working on a tokens handler, which client applications can use to get a refreshed ID token. And in our application, you might recall that we're actually going to renew or re-evolve the refresh token as well. This helps our client applications to maintain a sort of logged in state and access to their authorized user. Hasta pronto. Ciao.